Hello there, welcoming you all in the physics arena by Nitesh sir. Students, till now we have learned a lots of terms and definitions regarding with the topic sound energy. So via this video lecture today we are going to discuss about how to represent a wave like sound wave in the form of graph. So what do you mean by graph and how it can be denote or how it can represent a wave. So let's start with the topic. Representation of a wave. Students, as we are knowing that the wave is nothing but that is a vibration into a medium. So as a wave is propagating along the medium, so it can be determined or it can be described on the basis of the two factors, that is a displacement time graph. Means a wave can be described by the two ways. The first one is displacement time graph. Means in a particular duration of time how much displacement being happened, so that is a displacement time graph is the first one, and displacement distance graph. So the second one is the displacement distance graph. So students, one by one we will discuss about these two ways in order to understand how we can represent a wave. So let's start with the first topic, that is a displacement time graph. Okay, so the first one is displacement time graph. So what is the displacement time graph? Graph means that how we can define a graph. Graph is defined as it is a pictorial representation between the two variables is said to be the graph. So let us suppose that if we are having a wave produces the vibration in the medium is given by like this. So I am going to draw here a graph. So with the help of this diagram we will discuss more about the graph. So on x-axis, as we are knowing that there are the two axes in a coordinate system, that is the x-axis and y-axis. So onto the x-axis we will represent the time in t seconds, and onto the y-axis we will discuss the displacement occurred by the particle onto the y-axis. So let us suppose that when it was a rest condition, then there will be the particle at rest, means no vibration takes place. Okay, and here this is 1 plus 1, on the above of the vertical axis will be positive numbers, so it will be 1 plus 1 plus 2, and onto the below side of this origin it will be minus 1 and minus 2, because we are knowing that in mathematics there are the two types of the integer, positive integers and negative integers. Okay student, so here positive and negative. Let us suppose that the maximum amplitude gained by when the time t was 0, then the displacement was 0. At time t the particle reaches to the maximum displacement as 2. Okay, maximum displacement as 2, and after certain limit of time it reaches to again its mean position, and so it becomes a half cycle. After certain duration of time, the wave, now it is in the positive direction of the motion. Now the wave is moving into the negative direction, and also its vibration is maximum as 2. You can see here it is 2. Now after certain duration of time it reaches to its mean position. So first you can see that when the time t was 0, the body was at rest, and when the time t is maximum, the body vibrates maximum amplitude, that is A. So here you can see that the minimum vibration is 0 and the maximum vibration is A. So students, as I have drawn here the displacement distance graph, so how we could understand the representation of a wave with the help of graph. So here the y-axis denotes the displacement occurred by the wave, whereas the x-axis shows, here the y-axis shows the displacement and the x-axis shows that the distance occurred by the wave. So here you can see that the variation of the displacement of the particle of the medium at the different positions with the distance. You can see here, as we are increasing in the distance, the particle is having the different vibrations. You can see here at this point the distance is less and the vibration is also less. As we are increasing in the distance, we can see that the particles is vibrating once very smaller, and some at certain position it is having the maximum vibration, which is termed as a amplitude. And as we are knowing that the maximum displacement occurred by a particle is said to be the what? That is the amplitude. So here you can see that this is the amplitude. So at different positions with respect to the distance, there is a different, or you can say that with the variation in the distance by a particle, there is also the variation takes place in the displacement. Okay students, so what we can conclude that from the above figure, from above diagram, we conclude that what conclusion comes out? We conclude that variation in the distance, variation in the displacement of a particle, variation in the displacement of the particle of a medium, is different at different positions or distances. It means that as the distances changes, the vibration of the particle also changes. Sometimes it might be maximum, sometimes it might be minimum. So in this way we can calculate, in this way we can represent the variation in the variation which takes place in the position and vibration. Okay students, and as we are knowing that the distance covered by the wave in a specified duration of time, that is said to be the time period, is known as lambda, which is termed as a wavelength. So you can see here, this is a complete cycle. So the distance traveled by a wave in a complete cycle is said to be the wavelength. So here you can also see that from the rest position to the again rest position, the distance traveled by the wave is said to be the lambda, which is also known as the wavelength. Okay, so hopefully whatever the topics I have delivered here, you all are getting my points. If still you are having any doubt, students, you can come to me, you can contact to me, you can give the comment that sir, there is some issues. Have a nice day, keep learning, keep growing.